What's going on everyone, you're back with your boy Jono for another quick math lesson. Today we're going to have a look at adding and subtracting like terms, but we're going to look at the area model to represent algebraic figures. This is something that's going to help you visualize what algebra actually means and what the variables represent in any given question. So we know that a variable or a letter can represent any number. So that letter could represent 1, a million, -4, doesn't matter. As long as we know that there's a link between the letter or the variable and a given number, we know that we're going to be all right. So this lesson is going to be a little bit different. Instead of just using numbers and letters to do algebra, we're going to assign a shape to a specific variable, and then we're going to visually represent how we can add and subtract these values. The one thing that we need before we jump into this lesson is that we do need to know that the area of a rectangle is its side length multiplied by its width. So the two sides multiplied together. As long as you're on top of this concept, the visualization is going to be a lot easier moving forward. As a really quick example, if we had this rectangle and I asked you to find the area, all you'd have to do is multiply the two sides together. 5 multiplied by 8 is equal to 40, and that's the area of this rectangle. So that's the theory that we need in order to visualize this topic, but I think you're going to find it pretty easy. So to get this lesson started, all I want you to do is imagine that the variable a, right, this letter A, represents this rectangle here. So they're exactly the same. I'm saying that A is this rectangle. We could say that the side length is equal to A and the top of it's equal to 1, right? So if I had to find out the area of this rectangle, it would just be A times 1. And that's all we'd have to look at. So the reason that this is helpful is that if another rectangle comes along, another A comes along, I've got one A plus another A, and I can see them right next to each other. So I've got A plus A. So instead of writing it out as repeated addition, I want to write this in its simplest form or in a multiplication. The way that we can see what the area actually is that side length is still going to be A for both of these shapes. But up the top, because it was 1 and 1, if I throw that together, that whole top section is now equal to 2. Well, if I wanted to find the area of this rectangle, all I would have to do is multiply the side length A by the number 2, which is equal to 2A. This means that another way to write A plus A is equal to 2A, not A squared. If it was going to be A squared, both side lengths would have to be equal to A. And that is our next lesson where we multiply terms together. But for this one, we just have to add these two together. I've got one A, I've got another, bang, I've got two of them. 2A is the final answer. Just to hammer this point home, if I had 6 A's next to each other, like in this example, my side length is still A, and I have to multiply it by the 6 to find the area of all these shapes together. So this would just be equal to 6A. This means that A plus A plus A plus A plus A is equal to 6A, not A to the power of 6. Getting this really fundamental fact through is incredibly important moving forward because it's going to help us add and subtract these like terms incredibly easily. So the reason that we're assigning a shape to a variable is we can actually see very easily why we can only add and subtract like terms. We're going to see if we've got two different shapes, it's really hard to find the area very quickly because we're not just dealing with the same rectangle over and over again. So having an idea of why we can add and subtract like terms only is going to make it really hard to make mistakes when we're working out these questions in an exam condition. This type of question here is incredibly common. You'd be asked to simplify this expression. So we've got 3A plus 2B plus 2A, and we're asked to simplify it or give it in the simplest terms possible. It's very easy for students to be like, oh, well, it's 7AB, done. But if we assign a shape to each of these letters, we'll see that that's not going to be incredibly correct. So let's use the same rectangle from before. I've got 3 A's, 1, 2, 3, right next to each other. But then I've also at the end got 2 more of these rectangles, 2A. So I can see pretty easily that I've got these 5 rectangles that are all the exact same shape. But instead of B being the same rectangle, I'm going to draw it as a different shape. Maybe it'll look something like this. Well, I know that I've got 2 of them, not just 1, so I'm going to draw 2 on top of each other. Now all you've got to do is count up the shapes that you can see. Well, I've got 5 A's and I've got 2 B's. I can't just write this as 7AB because that's not what I've got. I have 5 physical A's and 2 physical B's, so my answer is just 5A plus 2B, done. So this type of question does trick students sometimes. What's really difficult to see is what is negative and what is positive because there's these signs all jumbled up throughout the question. what we're going to do is use the exact same shape to represent A and B. But this time, if it's going to be red, that means I'm taking it away. So for this, I've got 7A. I've got the same shape, that A rectangle, 7 times. And then I can see that I've got minus 5A. So what I'm going to do is on top of those 7A's, I'm going to put 5 red A's. These means I'm taking away those specific shapes, and all I'm going to do is highlight what's left over. So I've got 7A and 5 of them have been taken away, or I've put that red one on top of another one and they've been taken away. This just leaves me with 2 A's left. So I can find out pretty easily that my 7A minus 5A is equal to 2A. That's all the area that's left when I take these two things away from each other. That's usually pretty easy. Students are on top of this. But when the negatives, students are usually on top of this pretty easily. 7 minus 5, yeah, it's 2A, happy days. But it does get a little bit more confusing when the negative comes first. So for this one, I've got negative 2B plus 4B. So what I'm going to do first for this one is actually draw negative 2B first. I'm going to draw 2 red rectangles that represent 2B's, but we know that they're negatives because they're red. From here, what I've got to do is add on 4 normal B's, or 4 of these blue B's. The first 2 are going to cancel out the 2 negative B's that I had, right? They just go on top of each other. That's 2 of the 4 B's that I've got to put on. All I've got to do from there is add on the next 2 B's, and you can see pretty easily that the first B's got rid of each other, they cancelled each other out, and then there were 2 B's left over. So that means I've just got plus 2B. So the answer for this in total is just 2A plus 2B. So using an area visualization for this could help you add and subtract these like terms, especially when we're dealing with negative numbers. So the big pro tip for this is it's incredibly important to look at the signs of the terms before you just add or subtract them. If you've got negative 2B plus 4B, you've got to make sure that we are actually taking the negative first and then adding onto it. I would use different colors if you need to, just underline, making sure that you know if it's negative or positive to start, and then go from there. Some of these questions can be a little bit difficult, but I guarantee that if you take the time to really kind of think about it before we get started and visualize a model, I think you will find it a little bit easier to manipulate these numbers. Thanks so much for watching, and I'll see you later.